Hello, my dears. We are going to talk today about the last type of quadrilaterals, which is trapezoids. We have already talked about parallelograms, we've talked about the rhombus, we've talked about rectangles. So now we're going to talk about trapezoids. So what I did on my little cheat sheet here was I redrew a picture of an isosceles trapezoid right over here, just because, again, not enough space within this page here, within this picture. So I redrew one off to the side, and I'm going to label up that one that we just drew. So in a trapezoid, you only have one pair of sides that are parallel, and they are called the bases. So if you look at my picture here from Q to R and from U to T, these ones are parallel, and these are called the bases. So I'm going to call this piece up here base 1. I'm going to call this one down here base 2 so that we know what we're talking about when I start to reference them. The mid segment of the trapezoid connects the midpoints of the legs of the triangle. So the bases are these two in pink. The other two sides that are not parallel are called legs. So from Q to U, this is a leg. And from R to T, this is also a leg. The mid segment is this piece right here, and it is literally what it sounds like. It's the piece in the middle. So I'm going to kind of go over this one in my purple here. This is my mid segment. Okay. To figure out the mid segment, it's essentially just the average of the two bases. So in other words, to figure out what this mid segment is, you take the top base and the bottom base, you add them together, and then you divide by 2. So it's base 1 plus base 2, and then divide it by 2. So again, just finding the average between the 2 points, the 2 legs, two bases, well, it will give you what the mid-segment length is. So you're just finding the averages between the 2. Now, this picture here is called an isosceles trapezoid. In this picture, my legs, these two sides, they are congruent. So I'm going to put a tick mark to show that those two sides are congruent. Obviously, QR and UT, the bases, are not congruent. One's obviously very long, the other one's obviously very short. The other piece in here is that base angles are congruent. So in other words, if you've got 2 angles here, these are on the bases, they should be congruent. So for example, this one, angle U, is 80 degrees. The other one on the same base is also 80 degrees. These two should be the same. If you go to angles that are opposite of each other, they should be supplementary. Or in other words, they should add up to be 180. So angle T and angle Q should be supplementary because they're opposite. So since this is 80, this one here would have to be 100. Same for this angle R over here, but then of course angle R is also should be the same as angle U, or sorry, should be supplementary to angle U. So this one's also 100 degrees. So notice that the 2 angles on the same base are the same. 2 angles that are on the same leg are supplementary, adding up to 180. The last piece is that diagonals are congruent. So I'm not going to add it to this picture. I'm going to add it down here. Diagonals are the pieces, exactly like they sound like, are diagonal from one another. So they are congruent. So like this whole length right here, if this was 10 inches, then that means this whole length over here is also 10 inches. So full diagonals are also congruent. So we've got a lot of things marked in that picture. We're going to use that information and we're going to jump into our trapezoid notes. So in each picture, we're going to solve for X. I'm telling you that they are a trapezoid. And what I would like us to do is mark down the bases, the legs, and the mid segment. So in this first picture, my bases are the 2 that are parallel. So my first base is this one right here, KN. I'm going to put a B1 for the base. My second base is the other piece that is parallel, which is B2 down here, which is LM. And then this piece right in the middle is my mid-segment. Mid-segment. So remember, to find the mid-segment, we take base 1 plus base 2, and then we divide that by 2. So essentially, we're just coming up with the average of the two. So base 1 plus base 2 divided by 2. So my base 1 is 34. And actually, what I am going to write at the top, I'm going to write the equation. So the mid-segment equals B1 plus B2 divided by 2. Okay, so my mid-segment is x plus 17. And that should equal base 1 plus base 2 divided by 2. So 34 plus 20 divided by 2. Now, this is just some straight up algebra. What you can do is you can move over the divided by 2, or you can just do everything over here on the right before anything else. So for example, 34 plus 20 is 54. And 54 divided by 2 gives me 27. And then I want to get x by itself, so I subtract 17 from both sides. I get x equals 10. And there you go, easy peasy. Base 1 plus base 2 divided by 2. Number 2, my base 1 is the 13. My base 2 is the 33. And it doesn't matter if you flip-flop these. It doesn't matter which one's base 1, which one's base 2. The only part that's important is that this one right here is your mid-segment. So we take my mid-segment, which is 7x minus 12, and set it equal to base 1 plus base 2 divided by 2. So again, a little bit of algebra. So 13 plus 33 is 46. And if you take, oh no, it froze on me. There we go. Okay. So if you take 13 plus 33, add them together, you get 46. Divide it by 2, you get 23. Then I add the 12 to both sides to get my constants on one side. I get 7x equals 35. Divide both sides by 7, I get x equals 5. So it's just, again, a little bit of algebra, just like we've been doing this whole time. Number 3, same setup. My mid-segment, I'm just gonna put MS if you don't mind, is this one. Base 1 on the top, base 2 on the bottom. So my mid-segment equals base 1 plus base 2 divided by 2, the average. So 50 plus 20 gives me 70. Divide that by 2, you get 35. I add 7 to both sides, get my constants together. I get 42, and then divide both sides by 14. My x value is 3. So hopefully you're noticing it's a lot of like the same thing over and over and over again. Okay, one more time. And I'm gonna do this one a different way just so you can see another way to do it, but you can do whichever way makes your heart happy. So here's base 1, here's base 2, parallel sides, and then this one is my mid segment in the middle. So my mid segment equals base 1 plus base 2 divided by 2. So here's just another way to do the algebra if you like this way more, especially once we start getting into like some harder numbers. You can, instead of dividing by 2, you can get rid of that 2 by multiplying both sides by that 2. So we're getting rid of the divide by multiplying by 2. Okay, so on the right they'll cancel. On the left, you have to take that 2 and distribute it to everything inside. So you would get 10x plus 24 equals 21 plus 63. And then it is just like easy algebra from here. You've got 10x plus 24 equals, when you put these two together, you get 84. You subtract 24 on both sides. You get 10x equals 60, and then divide both sides by 10. You get x equals 6. So that's just another way to do the same problem. Still algebra, just we did it in a different order, and you can do it either way. You'll still get the same answer. All right, number 5. In this problem, you'll notice I gave you SQ, which is this length of 17, and I also gave you TR, which is x plus 13. Now, these are diagonals. And if I look back at my cheat sheet, I know that the diagonals inside of a isosceles trapezoid are congruent. That means they're exactly the same. So because these are the same, I'm just going to take the equations and set them equal. And then I just solve for x. And you get x equals 4. Easy peasy, right? So diagonals, we just set them equal to each other. Number 6, you'll notice, is the same thing. So x to z is 24. W to y is this equation. These again are diagonals. And since they are congruent, I'm just going to set the two equations equal. So 6x minus 18 equals 24. Get my constants to one side. I get 6x equals 342. Divide both sides by 6. X equals 7. And you're done. There you go. So now we've done the mid-segments. We've done diagonals. Now we're going to look at angle measures. So in number 7, you will see you've got your bases at the top. So this one's B1. This one down below is B2. Right? They are not the same. However, you've got two angles that are on the same base. So if I come back to my picture, two angles that are on the same base are congruent. So these are congruent angles. Because of that, I can set them equal. So I'm just going to take angle S or angle V, whatever, and set it equal to the other angle. That's it. So 8x minus 14 equals 50. I'm going to add 14 to both sides, get my constants together. 8x equals 64, divide both sides by 8. I get x equals 8. Next one, same idea. I've got a base GF and I've got a base HE. Now, what you will notice is that these two are not on the same base. They're across from each other. Because of that, that means, if I look at these two locations, these two are supplementary. Supplementary. So they add up to 180. So I need to write an equation that says if I add angle E plus angle G, I get 180. So I'm going to start by combining like terms. This gives me 100. Then I subtract my constant from both sides. And then I divide both sides by 8. I get x equals 10. And then I'm done. All right, last two. This time it asks me to find the measurement of the angles, which means I'm going to have to solve for x, and then I'm going to have to plug in for both of them. Okay, find the measure of angle C. Now, I've got two angles that are on the same base, so because of that, that means they are exactly the same. They're congruent, so I can just set the two equations equal. And do a little algebra. So I'm going to move my smaller x first. Then I'm going to move my constant. Divide by 2. I get x equals 10. Oops, sorry about that. X equals 10, but I'm not done. I need to plug in. And it's asking me for angle C. So angle C is 10 plus 7 times x, which is 10. So 10 plus 70. So the measure of angle C is 80, and we're talking about an angle. So I would use a degree symbol. Okay, last one. Number 10. Find the measure of angle V. Okay, so here is one base. Here's my second. These are not on the same base, so that means they are supplementary. However, I'm trying to find this angle over here, angle V, which has nothing with it. However, here's what I do know. I know angles on the same base are congruent. So in other words, angle V and angle W should be the same. Angle U and angle X are also the same. So if I figure out angle W, I'll figure out angle V. Now, I know these two are supplementary, which means I'm going to add them up to be 180 degrees. So I've got angle U plus angle W, and I set it equal to 180. So first I'm going to combine some like terms. 26x's plus 24 equals 180. Move my constant over. 156. Divide both sides by 26. I get x equals 6. Okay, so that's great, but now I need to figure out angle V, and remember, angle V and angle W are the same. So I'm going to plug in to angle W. That'll give me the same for angle V. So 16 times 6 plus 4. So the measure of angle V is 100. We're talking about an angle, so it would be degrees. So since this one is, since this one's 100, this one's also 100, which would then mean these are both 80 degrees because they're supplementary. Okay, and we're done. That was everything you need to know about trapezoids. So now you can flip it over to the back and give the trapezoid problems a attempt.